Hello, everyone, and welcome to this edition of the TNPS online seminar. We're delighted to have you with us. Before we begin the presentation, I'd like to share a few housekeeping items with you. This seminar is being presented in webinar format, so participant microphones and cameras are disabled. The Zoom chat is available throughout the presentation, so feel free to post your questions there as they arise. We will reserve time at the end of the seminar to answer as many questions as possible. The seminar is scheduled to last approximately 1 hour. It is my pleasure to introduce Dr. Richard Clements as our featured speaker this evening. Dr. Clements is a professor at Chattanooga State Community College and is the lead instructor for environmental science courses. He holds a bachelor's degree in biology from Tennessee Tech University, a master's in plant taxonomy from University of Tennessee, and a doctorate in plant ecology from the University of Kentucky. A recognized educator and naturalist, Dr. Clements received the Tennessee Science Teachers Association Science Educator of the Year for higher education in 2016 for leadership roles in promoting science and outstanding contributions to the science education that positively impacts the community. Dr. Clements also received the 2022 Harry C. Yeatman Award from South Cumberland State Parks for excellence in environmental education. Beyond the university classroom, Dr. Clements frequently leads exciting wildflower walks throughout the region. He is a popular field trip guide for annual Trails and Trillium wildflower event and for the Great Smoky Mountains Wildflower Pilgrimage. He is also an instructor for the Tennessee Naturalist Program for South Cumberland and Audubon Acres chapters. Dr. Clements, thank you for being here. The floor is yours.
Thank you very much, Mitchell, and thank you for having me. All right, we'll click on that, and we'll click on that. All right. Good evening, everybody, and thank you for coming to listen to this tonight. I'm going to turn the chat on because there will be a couple of times when I'll ask a question, and feel free to type your responses in the chat. So the title of this seminar is Native versus Exotic Species and Environmental Science Perspective. So I teach environmental science classes primarily at Chattanooga State. And so you're going to get a lot of introduction into the kinds of things I do with my students. So to get started with the presentation tonight, here's what we're going to kind of touch on. We're going to be looking at the idea of the big picture. And I got a big picture on the screen here. And we're going to talk about this picture quite a bit for the beginning of our little session tonight. We're going to rethink the environment. And one of my goals is to get you to think about the environment maybe a little bit differently than you currently do. We're going to talk a little bit about time and thinking about time and how time works. Not going to spend a lot of time on that, but I want that to kind of be a backdrop for things that we discuss this evening. We're going to talk about various factors in the environment that affect living things and plants especially. We're going to talk about the concept of disturbance and the concept of ecological succession. Not in great detail, and I expect many of you probably already know at least some of the basics of how succession works. But all of these things tie together to show us how native species operate, what happens when exotic species come into the system, and what some of the implications of that are. All right. So the big picture, and I expect Mitchell probably recognizes this scene. This is the start of the trail at the Big Soddy Creek Golf Park in Soddy Daisy, Tennessee, just north of Chattanooga. And we did a little field trip here this past spring. And as many of you probably do, you end up at a trail, maybe as a group with a wildflower walk, or maybe as an individual. But I want to stand at the start of this trail and just kind of look at what is going on here. And so we look at this, and to most people, it looks like it's the woods. That's about what you can say about it. And yeah, there's trees and there's vines and there's a path, but it looks like kind of a big jumbled mess. So let's kind of take a look at this big jumbled mess for a little bit and think about it in terms of the environment. Okay, so get your fingers ready to hit the keyboard in the chat. And I'm going to ask you this question. What is the environment? When somebody says the word environment, what's the first word or two that comes to your mind? What do you think of when you think of the environment? Okay, home. Lisa says home. Anybody else want to be brave and the world around you? Good. Conditions. Excellent. Climate and organisms. Ah ha 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 ha. Brittany, you hit it. Ding, ding, ding. Living and non-living factors. Okay. Kylie's a little bit ahead of the crew here. All right. All of these are perfectly good. The natural world. Yep, that's another one that comes up frequently. Uh, the natural world and surroundings. Those are two of the most popular answers. Uh, when I ask my students this question, and this is the first thing we do when we meet for the first time as a class. I ask them these questions and we just go around. What's the first thing that comes to your mind? Okay. And those are all perfectly good and legitimate answers. But hopefully, by the time we're done this evening, I'm going to have you thinking about it a little bit differently. And the next time you're out and about, the next time you're on a trail, the next time you're a participant in a walk, or maybe you're leading a walk, you'll look at things just a little bit differently. So let's take a look at this picture. What have we got going on here? Well, we have a path that's leading on into the woods. And it was warm. So I took this picture last Wednesday when I was preparing to take my students out last Thursday to this site for an ecology field trip. And it was plenty hot. It's hot out there in July. And there are trees. And we got tall trees and short trees, canopy trees, understory trees, oaks, maples, sweet gum, tulip poplar, lots of different kinds of trees hanging out there. And there's a kiosk up ahead. Kiosk has got information, a map of the area and a little bit of background about the information that that might be valuable to us as we're walking down the path. Oh, we got the humidity, right? We know it's not the heat, it's the humidity. And it's been plenty humid around here recently, which affects how we interact with the environment, mostly because our brains are thinking about getting back to the air conditioning. We have a disturbance along the edge. So along the right-hand side of this path, it's not really the woods that's a little bit further in, but it's not the bare path that's right here in the center. And we have a disturbance. People come through. The city of Soddy Daisy maintains this. And so they come through every once in a while with a mower. And they trim the edge of the path. And they'll do that several times during the year. Oh, squirrel. Right there. Do you see him? Zipped off the side there. Squirrels, chipmunks, other wildlife out here. Don't get me started about Joro spiders. We have the soil that the plants are growing in, and in some places you can actually see that where there's been some other kind of disturbance, maybe an animal burrowing or somebody digging doing some maintenance along the path. And of course, the soil is important because that's what the trees and the other plants are rooted in. We have the wildflowers. That's what people come out here to look at. That's what we want to see, the wildflowers growing in the woods and along the path. But in addition to the wildflowers, we got the weeds. We got all of this stuff happening. And where is most of that stuff happening? Well, it's happening in the disturbed area. And a lot of those weeds are things that would not normally be here if it weren't for the path and the disturbance. Okay. Underneath of all this, there's some bedrock. And where we are, we're still at the elevation of the Ridge and Valley Physiographic Province. And the bedrock underneath of us is going to be primarily limestone. Now, this path doesn't gain a lot of elevation, but we will see a lot of cliff sides, or there are a lot of cliff sides along this path. And eventually you get up into the point where the sandstone is going to be. And there's a lot of sandstone boulders found in this gorge that we're hiking up. Oh, there's a little hidey hole going on over there. That's where the little chipmunk's going to be, or maybe there's a snake in there, or maybe there's a possum curled up trying to get away from all of the people that will be walking down this path towards the swimming hole a little bit further down. Another thing that we have here, and I don't have a label on it, but another thing to keep in mind here is we have something else here. And what we have is history. This is what it looks like in 2026. But in 1926, 100 years ago, this looked a lot different because this was a coal mining area. And this was the road that went up to where a lot of the coal mining operations were. Now, the actual mining took place higher up on the plateau, and they would bring cars down and loaders down from the side of the gorge on the plateau and load up cars and at the tipples. And there was a railroad through here. This was a road through here. There was actually a little mining town back here with a company store and places for people to live. And you can go on the website for this area and download the little booklet, and they have pictures of what this looked like 100 years ago. And it looks very different today. So this place also has a history. There's a history here. But we still look at this and it's still kind of all over the place. There's labels kind of all over the place here. But human beings, way back in our lizard brain, have a very, very, very important survival strategy that we tap into all the time. And that's being able to take something that looks like a big mess and organize it. So let's organize this a little bit. And let's find the patterns. There's a pattern to what's going on out here. And so we can form 3 different groups of related things that make up the pattern of what we see. And so starting over here on the left-hand side, we have the temperature, we have the humidity, the bedrock underneath, and the soil. And those 4 things have something in common that allow us to group them like this. And these are not the only things that would go in this group. But can anybody think of what these 4 things have in common? I'm looking at you, Kylie Kilgore. Based on the answer to the what's the environment question. Anybody want to guess as to what those things have in common? These are all non-living things in the environment. And we call, or we refer to, I refer to when I'm defining the environment, the non-living factors, the non-living aspects of the environment. We group these together into what I refer to as the physical world. Temperature, humidity, bedrock, soil. Oh, but we can keep going. Weather, climate, average temperature, growing season, the air quality, how much particulate is in the air, how much ozone is in the air, soil chemistry. Even on the trail, and if we kind of look beyond the center list, I know it's a little bit light green, but you can see that there's areas of shadow and there's areas of sunlight. That's called dappling. And the dapples, where's the sunlight? Where are the shadows? How does the sunlight shadow change during the day and during the season? In the early spring, there's a lot more sunlight. Later on in the summer, there's a lot more shade and shadow. Things like topography. What are the high points? What are the low points? Which way do the slopes face? All of that and many, many, many more things are part of the physical world. Okay, so let's move to our center list of items. We got squirrels and trees and wildflowers and hidey holes. What do you think those are referring to? What do those things have in common? I'll bet some of y'all can figure that out. Okay. Well, what all of these things have in common is squirrels are alive, trees are alive. Here we go. Scott got there. Kyle got there. Wildflowers are alive. And hidey holes, well, what hides in hidey holes? Living things do. These are all things associated with life. And so we lump those into another group that we call the living world. Everything associated, the living things, but it's also the things that living things do. So the living world also includes things like pollination, reproduction, food supply, who's eating what and who's eating who, diseases that affect organisms. So all of the things associated with being alive make up the living world. And that's distinctly different than the physical world over on the left. So that brings us to our right-hand column. What do all of those four things have in common? Humans. Yep. And so all of this goes into the human world. Yes, we have to separate ourselves out. And I'll usually have a student who will say, but humans are alive too. And yes, we are. And yeah, we have to deal with a lot of the same issues that the squirrels and the wildflowers and whatnot have to deal with in the living world. But humans arguably have a different role to play in the environment. We have to deal with the physical world and the living world, but we also have our own world. And to this list, we could add, other aspects of the human world. It's not just that we make paths through the woods to go hiking and look at the trees and wildflowers and squirrels, but we also have things like art and music and religion and politics and history. And the historical aspect of this area is very much a part of the human world. And so when we begin to divide the environment up like this, we can very readily begin to see that, yeah, we've got this stuff that's the non-living physical world, and we've got the living things and all of the things that we do, that they do. And then we've got people and all the things that the people do in conjunction with the physical and living world. Now, all of the things on this list so far are nouns. But the environment is not just nouns. If everything was just nouns, it would be a pretty boring world. What do we need to make nouns more interesting? We need verbs. And so the primary overarching verb that relates all of this stuff together is interaction. And it's got that word action in it. Okay. There is stuff happening. There is stuff happening here. And there's stuff happening within each one of these worlds. And so we talk about interactions within. The temperature and the humidity and the climate operate on the bedrock and the type of bedrock to produce a particular kind of soil. Soils produced from limestone are different than soils produced from sandstone bedrock, and so many other non-living physical world factors, but all of these kinds of interactions going on within. In the living world, living things are interacting with each other. The squirrels are climbing the trees to get the nuts. The pollinators are flying among the wildflowers. Uh, Different species may be competing with each other for the hidey hole. Okay, the little chipmunk that runs in the hole sure hopes he doesn't run into a rat snake that's already there. Okay, because there's going to be an interaction there. Okay, namely, somebody's going to get eaten. The human world, we built the path, we maintain the side, which allows for the weeds to come in. So there are all of these interactions that take place within each one of the worlds. But it doesn't not stop there. Is the interactions that take place between the living things, do they just depend on what's going on in the living world and have no connection with anything else? I don't think so. And so not only do we have interactions within each of these worlds, but we have interactions between the worlds. And those are often some of the most significant. And so what I would offer you all this evening, yes, our surroundings, yes, our home, yes, the natural world, yes, climate, yes, different kinds of factors. But let's pull this together and think of the environment as the sets of interactions within and between the aspects of the physical world, aspects of the living world, and aspects of the human world. And when we think about the environment that way, does this scene look a little bit different now? When you stand at the beginning of a trail getting ready to go on a hike, can you see the human influence and the physical influence and how the different living things are interacting with each other, like the poison ivy vines growing on this sweet gum tree over to the left-hand side of the trail? Okay. So if you think about the environment a little bit differently, I think that's something that's very useful in our understanding of the natural world, our understanding of the human world, and I'd like to think our understanding of how we interact with the living and the physical, and how we manage, how we develop policy and things of that sort. Okay, let's shift gears a little bit. Let's talk time. So I've been prattling on now here for about 20 minutes, and we're only on what? The third or fourth slide? It's going to be a long evening. Not really, don't worry. So let's think about time for a little bit. There are 4 ways of thinking about time, and I'm only going to put 3 of them up on our screen here, but I'll mention the 4th one. We're used to human time and human time scales. Human time is what's happening now, maybe what happened just a little bit ago. I ate dinner a little bit ago. I still remember that. That's still part of my consciousness right now. And we think about time in terms of, well, the human time scale basically primarily focuses on our lifespan. So it stretches out to the next 6, 7, 8, 9 decades or so. And it's what we observe actually happening. It's where we can see things happen. We can see the movement. We can see the changes. Okay. The thunderstorm that popped up yesterday afternoon happened over a period of minutes to hours. It's right there on our time scale, and we can relate to it. And we're used to thinking about things happening on human time. Now, we can go beyond this a little bit. Our direct experience is kind of now and for however many decades in the future, and however many decades are behind us. But we also can think a little bit about, well, what are things going to be like maybe beyond that after I'm gone? And we can certainly look backwards and we can say, yeah, we know what things were like 100 years ago. We just talked about the coal mining at Big Soddy Gulf, and we just celebrated the 250th anniversary of the United States. But we know that things were very different here 250 years ago. And we can really throw our minds back to maybe 500 years ago at the beginning of the European invasion. The European exploration of the continent. But we know going back even thousands of years that no, Columbus did not discover America. He discovered a whole bunch of people who'd already discovered North America thousands of years before that. And but the further back in time we go, the more difficult it is to relate directly to it. So human timescales, that's what we kind of directly relate to. And it's how we kind of tend to operate. The next level up is what I call ecological timescales. This is kind of what the environment does on a more longer term timing, decades, centuries. We can see changes that take place over the decades. Today we were talking about the Great Smoky Mountains, and the Great Smoky Mountains. We're on the 100th year of it being proposed, but this is the 90-year anniversary of the dedication of Great Smoky Mountains National Park in 1936. But if you had been in that area and gone to the dedication and driven up Newfound Gap Road to Newfound Gap and watched FDR dedicate Great Smoky Mountains National Park in 1936, it doesn't look anything like it does today. It has changed dramatically. It's no longer open fields and farmlands and severely cut over forest. It's now a beautiful, fantastic, world-class biodiversity hotspot ecosystem. But it took decades to move in that direction. And any one person would have seen some changes happening slowly. But when you see the ends of it, it's like, wow, there's a lot that's happened. But it happened at a pace that we don't necessarily register. And then we have another time scale that we need to be aware of, and that's the geologic time scale. And now we're talking about things that take centuries, millennia, thousands of years, tens of thousands of years, hundreds of thousands, millions, tens of millions. It's a little bit hard to wrap our mind around the fact that the limestone bedrock under our feet at the beginning of the Big Soddy Gulf Trail was sediment on the bottom of an ocean 400 million years ago. What? Our brains begin to break at that point. But the geologic time scale is important. And it has been important since the beginning. And that sort of leads into the fourth one, which I don't have on there, but we could talk about the universe's time scale. The universe doesn't care about moments. It doesn't care about years or decades or centuries. The universe is operating on giga years, billions of years that things happen. Yet those changes that take place over the course of the history of the universe, the nearly 14 billion years, have a very direct effect on what happens and what's happening right now. I've kind of thought that one of the things I do is I'm an avid amateur astronomer and active in the Barnard Astronomical Society here in Chattanooga. And I've kind of given some thought to, it would be a really neat thing to talk about would be the astrophysics of wildflowers. It's a lot of neat stuff to unpack there. All right. So with this as kind of a background, let's look at a coreopsis up here at Big Soddy Gulf. And let's think about what this fella has to deal with. We've got this nice coreopsis. It's got a really nice bloom on it. It's got a lot of buds on it. It looks like it's doing pretty well, but it has to exist within the confines of a set of conditions that allow it to exist. And we call that set of conditions environmental factors. And we can divide environmental factors up into some categories because that's what people do. We categorize things and organize things. And so we can talk about abiotic factors. So when you see the letters bio in a word, bio, that makes you think about life. When you see the tick on the end of the word, that makes you think adjective. It's going to be describing something. But when you put the A in front of a word, that's one of the ways that we make a word mean not. And so abiotic factors, these are factors that are not directly associated with life or living processes. Or if we go back to the beginning of this evening, we're talking about aspects of the physical world. So we're talking about how much sunlight, how much shade, what's the growing season like, how much rainfall are we getting, what is the nutrient status of the soil, what is the pH of the soil, what's the drainage like of the soil, and so on and so on. Well, if we have physical abiotic factors, not probably going to be surprised to learn that we have biotic factors, things associated with the living world. Okay, so what are some of those that this coreopsis has to deal with? Is there a pollinator that can visit that flower and effectively transfer pollen between individuals of this particular species of coreopsis? Is there something that's going to come along and eat it? And we can kind of see up there in the upper right, there's been a bug nibbling on that leaf. Deer might come by and take a chomp out of it. So we got to worry about that. There might be some disease that can come in and make it less effective, make it ill. It's got to compete. It's dealing with the other plants around it. So there's competition with the other organisms that it's sharing this little patch of soil with. These are all biotic factors associated with living things. So I kind of threw out some examples there, but a way we can think about how these factors are operating for a given species in the environment, kind of like this. Have y'all ever seen one of these? This is a sound mixing board. There's probably one of these at your church. And there's somebody who sits up there and fiddles with these knobs and dials and sliders. Okay. And there's a lot of them. And we can think about the knobs and sliders and dials on the left-hand side as representing abiotic factors that influence this coreopsis, and the knobs and dials and sliders on the right-hand side as biotic factors that influence and affect this coreopsis plant. I don't know if any of you have ever worked with a sound console like this. I've watched people do it, and it's kind of interesting to watch them move those little sliders, and they twiddle those little dials, and they'll move it a fraction of a millimeter as if it makes any difference. I can't hear the difference, but maybe that's just me. But they dial it in and they get it all set up for whatever is happening on stage at the time. When a different act comes on stage or something different is happening, they reset the controls. So here the controls might be set for the factors for this coreopsis. But for another species right next to it, no, these dials and these sliders, they're going to be set differently because every species has its own requirements of abiotic factors and biotic factors. And there are many more than are even represented by the dials and sliders on this sound console. Now, for every one of the factors, though, for every factor that affects a living thing, there is going to be a perfect amount, a level where it's not too much, it's not too little, not too high, not too low. It's the Goldilocks zone, or the baby bear zone, I guess it would be, where everything is going to be just right. And we have a name for that. That's called optimal, optimal conditions, or the optimum. The thing is, the natural world is a complicated, messy place. And so it's not very often that an organism will ever find itself in a situation where every one of these sliders and every one of these dials is set to the exact precise optimum. That's just not going to happen. But luckily it doesn't have to, because organisms can function within a range on either side of that optimum, and we refer to that as the optimal range for each given factor. And as long as an organism is within the optimal range, within that range for all of the factors, it'll be good to go as long as it's in optimal conditions. But there is a little bit of a caveat there. When we have all of these sliders set and all these dials dialed in, there will be one factor, one environmental factor. It might be an abiotic or it might be a biotic factor that is going to be the furthest away from its perfect set point. And that factor is called the limiting factor. And that's going to kind of control everything that goes on. And that's going to be important. That's going to come up again and be very important in just a little bit. So hang on to that. Okay, how are we doing? Are we all kind of on the same page here? So what happens when the sound person gets all of those sliders and all of those dials dialed in just right for what's fixing to happen, and somebody who doesn't belong up there comes up there and trips and stumbles and falls on the sound console and moves all those sliders around? Somebody gets upset. Don't ask me how I know. What happens if those dials and sliders and those factors get moved? Well, this is called a disturbance. This is called disturbance. So disturbance happens a variety of ways. There are lots of natural disturbances. I'm sure many of you, most of you, all of you probably seen this happen in the woods. We get a good windstorm come through, and it doesn't just break the branches out of the tree, but it blows the whole tree over and pulls up the root ball behind it. This is called a wind throw. And this can be a big deal, especially if you get a lot of wind throw all at once. That it can be a pretty big disturbance. Or you might just get one or two trees in the woods that blow down in a given storm. People might look at that and say, oh man, that's not very good. That's kind of a problem. Um, well, maybe, maybe not. Things like fire. We get all warped out of shape about forest fires, but what we now understand is that fire is a natural, very important abiotic factor in the physical world that is extremely important in some ecosystems that allow them to function. Okay. And when we suppress the fire, when the humans interfere with that, that's a disturbance. Putting out every fire as soon as it happens, Smokey the Bear, preventing fire, that's actually a disturbance. And then when the fire does happen, it's much worse than it would have been otherwise if we hadn't been meddling with it. Of course, another disturbance, so we have natural disturbance, but then we also have human disturbance. So here's some logging that's been going on up at Prentice Cooper State Forest in Marion County, Tennessee, just to the west of Chattanooga. And here they've come in and cleared trees out of the forest. They didn't completely clear cut it. There are some places where they're clear cut, but they like to do a little more selective cutting at Prentice Cooper. But in other forests, especially in western forests, clear cutting is the economical higher profit. Ooh, economics and profits. That's a big important factor in the human world that has significant impact on the living and the physical world. Represents a significant disturbance. Development of land. That word development, that always has driven me crazy, because when somebody says, we're going to develop this land, the implication is we're going to make it better. Do we usually end up making things better? Is another new super Walmart really better? I digress. But we have human disturbances. Let's think about what disturbances do based on what we've discussed so far this evening. Disturbances disrupt interactions. Disturbances reset the sliders and dials. Disturbances change the abiotic and biotic factors and disrupt interactions. Okay? This has been going on for as long as there's been life on Earth. People have just done a lot more in the last 300 or 400 years. But when an ecosystem is disturbed, does it just stay that way? Is that it? It's just ruined and it's gone and we're never going to get it back? Well, no. The ecosystem will work to try and reestablish interactions. And it responds to this disturbance. And the response is to restore interactions, and through a process called ecological succession, restore something that is very similar to it. It may not be exactly the same, but it will be very, very similar to what was there before. And so the concept of ecological succession as being the response to a disturbance, the disruption of the interactions. So there's two basic flavors of ecological succession. The first is the first succession, primary succession. This is where we start with a clean slate and we're forming an ecosystem from scratch. Here we have a cedar glade in the Central Basin in Middle Tennessee. It's over in Wilson County. We can see, especially as we look towards the right-hand side of the image, lots of bare exposed bedrock. But as we move from right to left, we see increasing density of larger and larger plants until we get to the cedar forest on the left-hand side of our image. Primary succession starts from no system and is going to establish a new ecosystem. A great place where this happens is lava flows from volcanoes. This takes a long, long, long time. This is This is in that area between ecological timescale and geologic timescale. Because in order for primary succession to go from the bedrock we see on the right-hand side to the forest we see on the left-hand side, what do we have to make? What has to be built? What has to be generated? Go ahead and throw it in the chat. There you go. You have to make the soil. And soil takes a long time. It takes a long time. So we're not going to really worry too much about primary succession tonight. Instead, we're going to think a little more about secondary succession. So secondary succession happens when you have an established ecosystem, a disturbance takes place, and now we're going to go through a series of steps to recover from that disturbance. And so if we look in the background of this picture, we can see an agricultural field. It looks like they might have cut hay there. That might some years be a cornfield. We can see the rows and we can see where the farm equipment has been there. And so that area is continuously disturbed. But all around it and off to the right and off to the left, we see a forest, which is relatively undisturbed. That's the ecosystem that should be there. And then we have our disturbance, our farm field going on in the background. But then we look at the foreground. What has happened in the foreground? What's happened is we've quit running the farm equipment over it. We've quit planting corn. We've quit cutting hay. And secondary succession is going to kick in because the disturbance has stopped. And now, on ecological timescales, decades to centuries, we're going to go through a process. And the thing about succession is it's not just a random haphazard thing. This has been studied a lot. And when we have an old field, like what we see in front of us, as opposed to the new field in the background, yeah, this is called old field succession. Very well documented on how this takes place. It's not just, oh, we're going to throw a forest in there, but you start with the early successional species, the pioneer species. The broom sedge starts to grow. I love broom sedge. I'm a big fan of that. The blue stem comes in. The Indian grass comes in. And then not too many years later, the blackberry brambles show up and the sumacs start to grow, the shrubs and the small trees. But when they come in, they start to shade out the blue stem and the broom sedge. And then eventually some pines will start growing up. And that begins the process of shading out the brambles, the blackberries, and the sumacs. And eventually we get the oaks and the hickories and the maples, the temperate deciduous forest that we started with, that we can see back in the background, will eventually reform here, getting us back to where we were when we started. And that takes a period of time that we would measure in decades to centuries. A relatively fast event in the grand scheme of things. Okay. So secondary succession, we're recovering after a disturbance. All right. So now let's talk about this concept of native and exotic. And I've put these two terms in quotation marks because we need to kind of come to an understanding of what these words really mean. We typically use these words to say, oh yeah, partridge pea is native to Hamilton County, Tennessee. And Japanese stiltgrass is exotic in Hamilton County, Tennessee. We usually put a place name on there, our state or our county. But do plants and animals know anything about county lines and state boundaries? No. Do they know anything about country borders and immigration checkpoints? No. And so we need to rethink this idea of what it means to be native and what it means to be exotic. And so I'll put this out there for you. All living things are native to the planet Earth, as far as we know. Oh, we're looking for things elsewhere, but every living thing that we know of is native to that planet right there that we see. Okay. All living things are native to the Earth. However, not all living things are native everywhere. Have you ever noticed that not every species of every living thing is found everywhere? No, they're not. Why aren't they? Because every species of living thing has its own set of environmental factors that influence it and the optimal range for all of those factors. And it's only going to be found where it's within the optimal range for all of the factors that affect it. That's why not every species is found everywhere. This is why plants and animals and whatnot have geographic range distributions. They're found where the environmental factors allow them to exist. Now, we mentioned that thing about limiting factors, and there'll be a limiting factor that's the furthest and furthest from the optimum for that particular factor. Well, if you get too far away, you get out of that optimum range. And you might get into a range where it's still technically feasible for an organism to survive, but it may not reproduce very well. It may not be very healthy. And you probably won't find very many of them. And that's what you find on the edges of ranges. A lot of organisms, they're not found in one place, but as you move across the landscape, you start to see them. They start to show up. And I talk about this with my students. How many palm trees do we see in the forests of Tennessee? None, because we're not within the range of the environmental factors that support palm trees. But here in Chattanooga, we can hop on Interstate 75 and head south. And in a couple hours, you'll be in Atlanta. How many palm trees do we have in Atlanta? None. Keep going south. Get down there around Valdosta. Well, no, we're not quite into what you would call a lot of palm trees, but pretty soon we're going to cross into North Florida. Oh, there's a palm tree. And by the time we get to Orlando in central Florida, palm trees everywhere. Because we went from where the environmental factors were not favorable to where they were just beginning to be favorable to where they're within the optimal ranges for palm trees. I don't actually, instead of palm trees, I like Spanish moss. When I head to the coast, I look for when the Spanish moss starts showing up on the trees. That's a good indicator that you're getting close. Okay, so not all living things are native everywhere, and it's environmental factors that determine that. So, the way we need to think about native and exotic is that species are not native or exotic to places that we assign names to. China, southeastern United States, Tennessee, Sequatchie County, or whatever. Species are not native or exotic to places. Species are native or exotic to ecosystems. Species are native or exotic to ecosystems. Okay, so what does that mean? A species is native to the ecosystem that it developed as a part of, as the process of succession, primary succession, and then later on secondary succession. It is a species that occurs in that area because the environmental factors are favorable for it, and it is incorporated into the system. And it is interacting in such a way that it has what it needs to survive and reproduce, but it also has what it needs to keep it from overpopulating. There's regulation and control, checks and balances. And so a native species is a species that has developed with the ecosystem that it is naturally a part of. That's how I like to think of that. So then what's an exotic species? An exotic species is one that you take out of its native ecosystem and move it to a new ecosystem. And we now would say it's exotic to its new ecosystem. Now, when that happens, a lot of things can go on. Typically, what happens is not much. We move species around. So another aspect of the human world is we move stuff around like crazy, often intentionally, very often unintentionally. Okay, Joro spiders. Uh, but we move things around a lot. Many times when we move something from its native ecosystem to a new ecosystem, the environmental factors are not favorable for it. It can't establish any interactions and it just fades away. It's gone. We never even notice it's there. And a lot of ecologists think that that's what happens to the vast majority of species that get introduced to our ecosystems. We never even realize that it happened. There are a few that can become established, that can become incorporated and become a functional part of the ecosystem. And that's where I use the term naturalized species. Prunella vulgaris. It's not exactly taking over the forest. It just grows a little bit here and a little bit there, and it's fine. But then there are the ones that kind of get out of control. There are the ones that become real problems. And the problems occur most frequently when we move an ecosystem, when we move a species between similar ecosystems. And so here we're sitting here in Tennessee, about 35 degrees north latitude, between 35 and 36 and a half degrees north latitude. And if you were to draw a line on a world map right there around 35 degrees north latitude and draw it across the map, when you get to the other side of the map, do you know where you're going to end up? Somebody write in the chat, where do you think you're going to end up? Right around between about 34 and 36 degrees north latitude. Go east.
Japan.
You are going to end up in China and Japan, Southeast Asia. And where are most of our problematic invasive exotic species from? Surprise, surprise to absolutely nobody. Of course they're a problem because they're already used to what's going on here. Okay? That's why they are much more problematic. All right. Don't mean to gross you out too much here, but a way to think about what happens when an exotic species gets introduced. Think of it in terms of an injury. So a disturbance to an ecosystem is the equivalent of getting a cut in your skin, on your hand, on your finger. And of course, on your skin, there is a whole ecosystem of microorganisms. And most people, if you get a cut, what is going to be your response? Of course, after the language that you use and whatnot, most people would probably go wash it off, clean it up, put a dressing on it. And then it's going to heal up. And we can think of secondary succession as healing, the healing process when we injure or disturb an ecosystem. And so we wash the cut and it undergoes a normal healing process. And over time, there might be a little scar left, a little indication that at one time something happened there. And yes, ecologists and people who are very familiar with this kind of thing can go into a forest and say, yes, this is not an old growth forest. This is a second growth forest because there are signs that we can see, but it's still a functioning, healthy, in case of East Tennessee at least, temperate deciduous forest ecosystem. But what happens if you don't clean that wound? And especially if maybe you get cut with a rusty object. Okay. Something else happens. What's going to happen? Type it in the chat. What's going to happen if you don't take care of that? There you go. You're going to get an infection. And that is going to significantly alter the healing process. It may extend it for an extended period of time. It may never heal back correctly. You could die. There was a time before penicillin when if you got a cut like that, your life expectancy was significantly shortened. Okay. So whenever they say, boy, things were sure a lot better way back then, no, they weren't. And that's what invasive exotic species kind of represent. They represent an infection when the system is injured, when there's a disturbance and factors and interactions are altered. Invasive exotic species have an opportunity to get in, and they're already primed because they're already adapted to most of the abiotic factors and many of the biotic factors, except they don't have the things that eat them. And as a result, we see a disruption of the secondary succession healing process and displacement of native species. So here's the path that we looked at earlier. And here we can see a disturbance. This is the ditch, the drainage ditch on the side. But if we look down here at the bottom on the left-hand side here, oh boy, there's our infectious agent. And next thing you know, we see what we see on the right-hand side, the Japanese stiltgrass coming in and taking over and outcompeting the native species and displacing our native species. And that's when exotic species become invasive and problematic. So to kind of sum it up here, I think I'm coming in fairly close on my time. We're rethinking the environment as a set of interacting systems, interactions within and between the physical world, abiotic things, the living world, biotic things, and people who tend to meddle with things to a pretty significant extent. Species have a specific set of factors and interactions that allow them to exist as part of this thing that we call an ecosystem. Disturbances change those factors and disrupt those interactions. Succession works to restore the interactions and sort of reset things. Okay? Species are native or exotic to ecosystems, not places. And invasive exotic species are species that can disrupt the reset or the healing of an ecosystem through the process of secondary succession. All right. So that's what I wanted to talk about this evening. And I appreciate y'all being here. And if anybody has any thoughts they'd want to add or questions they want to ask, I'll be happy to hang around and chat with you.
Thank you for that excellent presentation. Very thought-provoking and very useful in terms of new ways for us to think about the matter of native versus exotics. We would like to see any questions you might have from our audience. I think you might have covered things so well that you answered all of our questions.
Well, maybe I ought to give a test.
Well, we have the names, we can, and email addresses, so.
Well,
Yeah,
I hope that you come away from this thinking about things maybe just a little bit differently,
absolutely.
and that'll come in handy for you at some point. So thank you all for putting up with this.
Well, we're having a lot of thank you show up on the chat now. So we really appreciate you taking the time and going through this. And I certainly appreciate the background slide that you used. That's one of our favorite places to go out and enjoy nature.
Well, now the next time you're out there, you're going to look at it a little bit differently.
I will definitely be looking at it differently and thinking about hidey holes.
Yeah, but you got to be careful around them.
I know, I know. I didn't say I was going to go in one.
Well, thank you all. Thanks for having me and asking me, inviting me to do this, Mitchell. I appreciate it a lot. It's been a lot of fun.
Well, we thank you. And as I mentioned earlier in some emails and on the Facebook, we are recording this, so it will be available for anyone who would like to go back and review some of the things that were covered and or share it with others. We appreciate all of you attending tonight. And if there are no further questions, we will end the session for tonight. But much appreciate your time and your information that you've shared tonight, Dr. Clements.
Thank you all very much for having me.
Well, good night, all.
Night, everybody. Stay safe out there.